Hi, welcome to the Lecture 12 review video about chemical names and formulas. My name is Dallin Davis and I will be presenting this review. I hope you enjoyed and that you get something out of it. So the main topics of this of Lecture 12 was about naming compounds. And so the three main topics are about naming different types of ionic compounds, naming different types of acids, and the naming of covalent compounds. And so we're going to start off with ionic compounds. But before we do that, we kind of need to do a quick review real quick about ionic compounds. So ionic compounds are made of cations and anions. Cations are positively charged ions, and anions are negatively charged ions. And so when we name ionic compounds, the first word when we name them will always be the cation, or the positively charged ion. And when we're naming it, we just leave it as is. And we'll have some examples towards the end of the section. And then the second word will always be the anion of the compound. And this one will always end with an "ide." A great example of this would be sodium chloride. The sodium part is the cation, the positively charged ion, and it's just the same, it's just sodium. But chlorine has been changed to chloride, and that's essentially how you name ionic compounds. So I just want to pop in here. So the first time that I was recording, I sounded completely dead inside because it was super late. So I want to apologize for that. But I'm going back now and I'm adding some extra stuff, so you're going to be able to tell at certain parts of the video I'm going to sound a little bit different. Hopefully more alive. I'm not sure. We'll see. And I would redo the whole thing, but I'm too lazy, so I'm not going to. So I personally learn best through examples. So we're going to do a few examples of how to do ionic compounds, and then I'm going to go back and add in extra examples for each of the sections to help you understand those parts as well. So a few examples of ionic bonds and their names. So it's always going to be between the alkaline or the alkaline earth metals, and then a non-metal. So a good example of this would be a combination of lithium and fluorine. It's like how we were talking about before. The first one, or the positively charged one. So yeah, so how we were talking about it before, it always starts with the cation first, and then the anion. In the example of lithium fluoride, it's a combination of lithium and fluorine. So lithium is the cation, and fluorine is the anion. And so the cation goes first, lithium, followed by fluorine, but you change the last bit to "ide." So it becomes lithium fluoride. The same thing goes for lithium chloride. Lithium is the cation, chloride is the anion, with just "ide" attached to it. And they're all the same. Another great example would be sodium iodide. That would be a combination of sodium and iodine. But you just change that last bit of iodine to iodide. But yeah. And so that's all there is really to ionic compounds. Polyatomic compounds are a little bit more difficult, polyatomic ions are a little bit more difficult. Polyatomic ions are essentially atoms that are covalently bonded together, but they in themselves are an ion because they have a negative charge. And these ones are tricky because there's no trick to naming them. They just have names. So a few examples of these are ammonium, nitrate, nitrate, phosphate, phosphite. And they're really tricky, and the only way to really be able to know how to name these is just to memorize the formulas and the names. Thankfully, there's only a few that we have to know for Chem 105. And here's a list of them right here. But yeah, so essentially it just comes down to memorizing these, and I wish I could tell you a better way, but sadly there's not. So a few things that I've noticed while studying the polyatomic ions that we're supposed to memorize. Something that's kind of helped me is that the differences between the sulfate and sulfite is that the sulfate, or rather So a few things I've noticed while trying to memorize the polyatomic ions is that there is a way to tell which of the ions end in ate or ite. The ion with the greater amount of oxygen atoms will be the ate version. The problem is that they're not consistent in how many oxygens there are. For example, sulfate has 4 oxygens, while chlorate has 3 oxygens. So that becomes a little bit complicated. But as long as you can remember at least one of them, so just drill into your head, oh, sulfite has 3, and then if they show you an option with 4, you're like, oh, that must be sulfate because it has more. And that's pretty much the only tip I can think of to help with that. That's the only thing that's really worked for me. And what I recommend doing is what I did is I just wrote out a bunch of flashcards with like the Lewis structure of the ions, because just being able to visually see what they look like helped me a lot. For example, oxalate, the Lewis structure is it kind of looks like an X, which helped me remember that because it's the only ion that's like the X is super prevalent, the oxalate, so that helped me memorize that one. So I definitely recommend using flashcards to be able to help remember these. But yeah, best of luck in remembering these. Naming hydrated salts. So when hydrated salts are essentially a salt, which is a nonmetal and a metal that are ionically bonded together. A hydrated salt is when water molecules are introduced, and the water molecules essentially sit inside the salt crystal kind of lattice. Kind of if you think about like salt crystals forming like a sort of like a bunch of boxes stacked on top of each other, and when they're hydrated they just have like water molecules in those boxes. And so how you go about naming these is that you name the salt the same way as you normally would. An example of this would be iron chloride. But when water is introduced, you add an additional part, which has the prefix of how many there are. And here's a list of all of the prefixes. For half a molecule of water, you'd use a hemi. For 1 molecule, you'd use mono. For 2, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, nona, and 10, deca. So you add a prefix to the word hydrate. So our iron chloride becomes iron chloride hexahydrate if it has 6 molecules of water that are sitting inside those salt crystals. And that's essentially everything you need to know about ionic compounds. So let's do a few examples of hydrated salts. So here's a good example. So we have the salt of sodium carbonate, and when it's hydrated, it has 10 moles of water molecules inside of it. So the way we named this is first we write it out as Na2CO3, which is sodium carbonate, and then we put a little dot, which is like, I guess, just implies that they're together, and then we do 10 H2O. And the way we name this is just sodium carbonate, the name of the salt, decahydrate. And so the deca comes from the fact that there are 10 of them, and the hydrate is just implying that there's water, or that it's a hydrated salt. Another good one would be, let's see here. So if you hydrate sodium tetraborate, which is actually borax, it also has 10 moles of H2O. So this becomes sodium tetraborate decahydrate. So as you can see, it doesn't really change the name of the salt itself. It just kind of adds on to it. And so all you have to remember is that you have to add hydrate with the prefix in front of it to imply how much there is. And that's all there is to it. So acids, there are only 2 types of acids that you need to know how to name: binary acids and oxoacids. Now, you may be asking yourself, what are binary acids? Great question. Binary acids are a compound of hydrogen and one other non-metallic element. An example of this would be hydrogen and chlorine. And so to name these, essentially the name of the compound is just a variance of the second element, because every single binary acid will have hydrogen. So that's not really a part that varies when you're naming these. So this first step is based off of your second element, you're going to add hydro to the front of it. So for example, if we have a chlorine bonded to hydrogen, we add a hydro and then you add on to the chlorine. So right now we've got hydrochlorine. And then the second step is that you just change the last syllable to an ic. So chlorine becomes chloric. And then you add acid to the end. So our hydrogen bonded to chlorine becomes hydrochloric acid. So real simple, you just add hydro, change the last syllable to ic, and it's an acid. Boom, add acid to the name. You're done. Hydrochloric, hydrofluoric acid. It's pretty simple. So let's let's do a few examples of binary acids. So let's see, what's a good example? Let's go with a combination of hydrogen and fluorine. So, like we said before, it's all based off of the element that's not hydrogen. So in this case, that would be fluorine. So all you need to do is add hydro, so it'd be hydrofluor, and then you change the last syllable to ic, so it becomes hydrofluoric acid, and that's all there is to it. And we can do the same thing with iodine, for example. So it's hydro, ion, like iodic. Instead of iodine, you change the last syllable to ic, so it's hydro. It's a hard one to say. Hydroiodic acid, and that's all there is to it. We can do it with bromine. So it changes. So you add the hydrogen to the bromine, and you get hydrobromic acid, and that's all there is to it. Yep, that's it. The other type of acid that you need to know how to name are oxoacids, which are acids that are formed from oxoanions. So quick review. What are oxoanions? Oxoanions are anions, or negatively charged molecules that contain oxygen. A few examples of these would be nitrate, nitrite, sulfite, and these become oxoacids when you start to introduce hydrogen, much like binary acids, which were just one element, but once you added hydrogen, it became an acid. The same thing is happening here. It's just with a more complicated oxoanion. So how do we go about naming these? So these ones are a little bit more complicated. These depend on the oxoanion and the name that the oxoanion actually had. So if the oxoanion ended in ate, we change it to ic. For example, nitrate becomes nitric. And if it ends in ite, it becomes, we change that to is. So nitrite becomes nitrous. And then you just add an acid on there, and voila. And here are a few examples of that. Okay, so let's do a few examples of oxoacids. So as we discussed before, you just start out with your oxoanion name, and then you change it based off of its last syllable. So an example of this would be nitrate. Nitrate becomes nitric acid. But on the other hand, if you take nitrite, that becomes nitrous acid. Another example would be sulfate. It becomes sulfuric acid. Now this one's a little bit different because you have to add the R for it to work, but it still ends with the ic. That's what's important. There's something similar with when you take phosphate and you add the hydrogen, it becomes phosphoric acid. But yeah, the most important thing is that you remember that ate becomes ic and ite becomes is, and as long as you're able to remember the oxoanions, you should be able to remember which becomes which. Naming covalent compounds is probably, in my opinion, the easiest kind. So covalent compounds are also known as binary molecular compounds. Or essentially, this is when there are two elements that are bonded together. And what's nice about this is that it's very simple and it's always the same on how to name these. So there's two parts to name these. The first part is the first element and has a prefix based off of how many there are in the compound. And this is very similar to what we were looking at earlier with the hydrated salts, with the mono, the di, the tri, the hepta. So you just see how much there is of an element, and then you add the number prefix to it, and that's the first part. The second part is you take the second element, you also add its prefix depending on how much there is, and then you change the end to "ide." Kind of like how before where we had to change the last syllable to "ick," but in this case it's just "ide." Okay, so let's do a few examples of naming binary covalent compounds. So we'll start with combining just one atom of nitrogen and one atom of oxygen. So we start with our first element. We look at it and we see, oh, okay, so it's got one atom of nitrogen. So normally it would be mono, but because it's the first one, we don't need to do that. So it just becomes nitrogen. And then we look at the second one. We say, okay, so there's one oxygen, so that it becomes mono. And then we take the oxygen and we add an "ide" to the end. And so this becomes nitrogen monoxide. And on the other hand, if we have N2O, so there's two atoms of nitrogen, this becomes dinitrogen monoxide. So we've got the prefix for the nitrogen, which is 2, which is di, and then we also have the prefix on the oxygen, which is mono, and then we have the "ide." Okay. Let's do another example. Let's say we have two atoms of sulfur and two atoms of chlorine. So how do we name this? So we look at the first one. Okay, so there's two, so it's disulfur. And then we look at the second one. It's like, okay, so there's two of chlorine, so it's dichlor. And then we change the last syllable to "ide, so it becomes dichloride. All right, now let's say that we have one with a slightly bigger number. Let's say we have 2 atoms of chlorine and 7 atoms of oxygen. All right, well, let's just start with the first one. So we've got 2 of chlorine, so that becomes dichlorine. All right, and then we've got 7 of oxygen. So the prefix for 7 is hepta. But because oxygen starts with O, we don't need that A there. So it just becomes heptox, and then we end with an "ide, heptoxide. So this becomes dichlorine heptoxide. And that's all there is to it.